Hey everybody, Mr. Cozad here with a calculus lesson for you today. Finishing up our lesson series on u-substitution, integrating through u-substitution. Specifically today, in this set of problems, we're going to look at how we handle negative exponents, and then we're going to transition from indefinite integrals, which is where we've been so far, and we're going to look at how do we apply u-substitution to definite integrals. So if you would, either print the notes from It's Learning, or you can just pause the video and write the problems down as we go through them today. Either way that works best for you. Here you go. We're going to go through, I believe it's 8 problems together today that will finish up our series on u-substitution. Okay, so here is the first problem. Okay, so this is obviously an integral that's set up very similar to what we've seen. The only difference here is now we've got an expression that's in the denominator of a fraction. So the very first thing that I would have you remember is that we could rewrite this integral as negative 4x, and we're going to move the 1 minus 3x squared up to the numerator. And the way we can do that is we can make that exponent negative. So we'll think of it as negative 3. So then we're right back to where we were with u-substitution. We're going to let u, in this case, be 1 minus 3x squared. We take the derivative of u, and we get negative 6x dx. I divide both sides by my negative 6, and I get negative 1/6 du equals x dx. Okay, so now what I can do next is I can rewrite this integral using u and du. So if I rewrite that integral, I get u to the negative third times, should have actually slid out that negative 4 there at the beginning, so let me do that. Let me slide the negative 4 constant out to the front of that integral. So I have u to the negative third times negative 1/6 du. So then that negative 1/6, I can also slide that out to the front to make that a positive 4/6 times the integral of u to the negative third du. So now I can integrate this, okay? Now remember, with our negative exponents, we're going to add 1 here to the exponent, so that's actually going to become u to the negative 2 power, and I'm going to multiply that by negative 1/2, and don't forget your plus c since it is a indefinite integral. So we could take our 2/3 and multiply it by negative 1/2 and then substitute back in for u. So we'd have negative 1/3 times 1 minus 3x squared to the negative 2 power plus c. That would be my final answer. Now I went pretty fast through that, so you might need to go back and re-watch that again, or pause and kind of think about what's happening there. But that is how we handle those negative exponents. Okay, let's look at another problem. So our next problem is the integral of 3x over the cubed root 4x squared minus 1 dx. So the very first thing I'm going to do is I'm going to rewrite this, and I have to remember 2 things. Number 1, I have to remember that when I move this expression in the denominator, when I move this up to the numerator, it becomes a negative exponent. And I also have to remember how to write the cubed root as a rational exponent. So I'm going to rewrite this as 4x squared minus 1 to the negative 1/3 power. It becomes negative because I move it up to the top, and I can rewrite cubed root as 1/3 power. So then I'm ready to do my u substitution. So I pick, for u, I'm going to pick 4x squared minus 1. du then gives me 8x. Divide both sides by 8, so I get 1/8 du equals x. Oh, I forgot my dx. Equals x dx. So then you can rewrite the integral. Slide the constant 3 out in the front, and you've got u to the negative 1/3 power times 1/8 du. So next you can slide the 1/8 out to the front, so that's 3/8, and then we can integrate u to the negative 1/3. So that's going to be u to the add 1 to negative 1/3, and remember adding 1 here is the same as adding 3 over 3, so that's going to become u to the 2/3 power, And since I don't see a 2/3 in front of u in the integral, I'm going to multiply that by the reciprocal of that exponent. Don't forget your plus c because it's an indefinite integral. So then all I'm going to do is I'm going to clean this up and sub back in for u. So this becomes 9/16 when I do 3/8 times 3/2. And I sub in for u 4x squared minus 1 to the negative 1/3 power. I'm sorry, totally wrong. I was looking up at the integral. Let me fix that. You probably know that. It's to the 2/3 power. To the 2/3 power plus c. Final answer. Next problem. Okay, here we're doing the same kind of deal with negative exponents, but we're going to apply some trig. All right, so we're going to rewrite this first of all, and we're going to move cosine of 5x to the 4th power. We're going to move that up to the numerator. And again, I'm going to do two things here. I'm going to leave sine 5x, and I'm going to multiply this by, here's how I'm going to write this. I think it's easier with this, trigonometry and doing u sub to think of it as cosine of 5x to the negative 4th power. Cosine 5x to the negative 4th power is in my opinion, an easier way of approaching this problem because that makes the u substitution a little bit more obvious to us. We see that u is clearly cosine 5x. Now you have to be really careful when you take du here because you actually have to apply the chain rule. Okay? So we start by taking the derivative of cosine. The derivative of cosine gives negative sine 5x. But the chain rule tells us that to take this derivative, we have to actually multiply by the derivative of the inside as well. So the derivative of 5x here is just 5. Don't forget your dx. So now what I have is I take the negative and I take the 5 and divide it to the other side. That's dividing negative 1/5 du equals sine 5x dx. So now we can rewrite this integral in terms of u and du. So we can rewrite it as the integral of u to the negative 4th power times negative 1/5 du. Slide your negative 1/5 out to the front and then actually take the integral of u to the negative 4th. So we add 1, so that's going to become u to the negative 3rd. And then I don't see a times negative 3 on the front of the integral, so I'm going to multiply that by the reciprocal, which is negative 1/3. And again, don't forget the plus c. So now I can just multiply the negative 1/5 times the negative 1/3, so I get 1/15 times cosine of 5x to the negative 3rd power plus c. Now if you wanted to write this in another way so that you didn't have any negative exponents, we could just move that cosine 5x back down into the denominator. And then that would become a positive 3 plus c. So either one of those would be okay with me for right now. I mean, ideally I'd like for you to get rid of negative exponents, but for right now where we're at, either one of those would be great for us. Okay? So moving on, we got one more with negative exponents here. So I'd like you to maybe pause the video here, and I'd like you to maybe try this one on your own. See if you can figure this out. Give it a shot. See what you can do. And either when you get stuck or you get finished, jump back in the video, and you can see how you did. Okay, welcome back. Hopefully you gave this a try. If not, you're just back with us because you just want to get this video done. Okay, I understand that. So first thing I'm going to do is I'm going to rewrite this as the cosine of square root of x times x to the negative 1/2 dx. I did two things there. I moved the x to the, I thought of the square root of x as x to the 1/2, and then I moved that term up to the numerator to get it to be x to the negative 1/2. So now u in this case, okay, for u, I'm going to let u be the square root of x. du equals 1/2 x to the negative 1/2 power dx. So if I want to move this 1/2 to the other side, I do that by multiplying by 2. So we have 2 du equals x to the negative 1/2 dx. So now I can rewrite this integral in terms of u and du. So I've got the cosine of u times 2 du. So then what I can do is I can slide this 2 to the outside of the integral, and then I'm actually going to evaluate that integral. Okay? So the integral of cosine is sine u plus c. And then I simply rewrite that using subbing back in for u. So I have 2 sine square root x plus c. I think the problem with a question like this for some of you may have been, what do I pick for u? Okay, and remember with trig functions, you generally speaking want to at least try plugging in whatever you're evaluating the trig function of. So in this case, I was evaluating the trig function of square root x. So start with that, try it, and see if it works. Luckily, it did work for us in this case. The other thing that might have been a little different is handling this negative 1/2. Remember, we multiplied both sides by 2 to move it to the other side so that I could rewrite the integral in terms of u and du. Okay? All right, so changing gears to kind of finish out this lesson today, we're going to look at definite integrals. Okay? Now, I know this is a definite integral because I clearly see an upper and a lower bound. Okay? Remember, the number on the top is called the upper bound. The number on the bottom is called the lower bound. Okay? So what we're going to do here, we are going to do this problem like u-substitution, just like we normally would. There's really just one change to how we approach this. Okay? U-sub is the same thing as we've done. So we're going to let u be x squared plus 1. So du would be 2x dx. Divide both sides by 2, so we get 1/2 du equals x dx. Now, before you rewrite this integral, okay, what we're going to do is we're actually going to change the upper and the lower bounds. We're not going to use 3 and 1 anymore. But what we're going to do is we're going to take those bounds, okay, to change them, and we're going to drop them into whatever we picked for u. Okay, we're going to drop them in whatever we picked for u. So our upper bound, we're going to take x equals 3, and we're going to drop that into u. So we're going to take 3 and plug it in right here for this x. So 3 squared is 9. 9 plus 1 is 10. So our upper bound changes to a 10. Okay? Do the same thing for our lower bound, but this time you're going to take 1 and drop 1 into u. So we've got 1 squared is 1, 1 plus 1 is 2. So we changed our bounds. Our upper bound is now 10, our lower bound is now 2. So then we're going to just rewrite this just like we've been doing with u-substitution. So we're going to write it as u squared times 1/2 du. We're still going to slide the 1/2 out of the integral. And then we're going to actually evaluate this integral for u squared. So that becomes u to the third, because we add 1 to that exponent. And then I multiply that by 1/3. Now here you don't need a plus c because it's not an indefinite integral anymore. We have an upper and a lower bound. Now before you sub x squared plus 1 back in for u, we actually kind of already did that work when we changed the upper and lower bounds. So the next step on this is actually really easy. You can just take the upper bound and plug it in for u. So that's going to be 1/6 times 10 to the third power. And then we're going to subtract the same expression, that integral, where we plug 2 in for u. So that's going to be minus 1/6 times 2 to the third power. The whole advantage back here of changing our upper and lower bounds is it makes evaluating this definite integral a lot easier because you don't have to worry about plugging back in for u. Okay? So then if we clean this up, we've got 1/6 times 1,000 minus 1/6 times 8. So that ends up getting us, if we combine those like terms, I trust you to be able to do that. We end up getting 992 over 6, which we can simplify as a fraction to 496 over 3. Okay? So the takeaway from definite integrals is you're going to adjust your upper and lower bounds depending on what you select for u. And then after you evaluate that integral, like we did right here, you do not have to sub back in for u. You can just use your new upper bound and your new lower bound and substitute those directly in where you have your u. Let's practice another one of those. Any day now. Okay, there we go. So, again, definite integral because I have a lower bound and an upper bound. Okay? So I'm going to go ahead and set u as x cubed minus 2 du equals 3x squared dx. Divide the 3 on both sides so we get 1/3 du equals x squared dx. Now we can rewrite this integral, and I'm going to do two things. I'm going to rewrite it in terms of u and du, and I'm also going to adjust the upper and the lower bounds. Okay, the upper bound I take 4, and I'm going to drop that in for x. So 4 to the third power is 64. 64 minus 2 gets me 62. To find the new lower bound, I'm going to take -1 and drop it in for x. So -1 to the third is -1. -1 minus 2 gives me -3. So there are my new upper and my new lower bounds. We're going to be happy that we did that after we evaluate this integral. Okay, so I also notice in my integral I had a 9 that I can slide out to the front. So I have 9 times the integral of u squared times 1/3 du. You can slide the 1/3 out as well, so 9 times 1/3 would give me 3. And that's going to be u to the third power if I add 1 to u squared, and then I multiply that by the reciprocal of that exponent, which is 1/3. And we're going to evaluate that from -3 to 62. So we plug in 62 for u in our, do we do that first? So 3 times 1/3 cancels out, so it's just 1. So we're going to do 62 to the third power, which is a huge number, minus lower bound, -3 to the third power. All right, so 62 to the third power, you would absolutely have a calculator to help you get that. 238,328. And -3 to the third power is -27. So when we subtract -27, that turns into +27. So we finally add those together. We get 238,355. That's our final answer. This really isn't that bad, especially if we adjust our upper and lower bound. It makes the substitution pretty easy at the end. All right, next problem, number 7. Any day now. Here we go. Evaluate each. All right. So we're going to set u as 2x minus 1, and we're going to make du 2 dx. Divide both sides by 1/2, and we get 1/2 du equals dx. So we can rewrite this. Before I do it, I'm going to pause and let you try to rewrite this using adjust your upper bound, adjust your lower bound, and substitute in for u and du. Okay, hopefully you actually tried that. Here's what it would be. My new upper bound, if I plug a 5 in for x and u here, 2 times 5 is 10. 10 minus 1 is 9. So my new upper bound becomes 9. and then I drop a 1 in for x. 2 times 1 is 2. 2 minus 1 is 1. So my lower bound stays at a 1. Okay. All right, so then I can rewrite this function as u to the 1/2 power times 1/2 du. So I can slide the 1/2 out to the front, and then I'm actually going to evaluate this integral. So if I add 1 to this exponent, 1/2 plus 1 is u to the 3/2 power, and then I multiply that by the reciprocal of the exponent, so 2/3, and we're going to evaluate this from 1 to 9. Now again, you do not, on these problems, need to sub back in for u because you already adjusted your upper and your lower bound. So 1/2 times 2/3 gives me 1/3 times 9 to the 3/2 power, and then I subtract 1/3 times 1 to the 3/2 power. So then we can evaluate each one of these. I end up getting 9 minus 1/3, which gives me 26/3. Final answer. And those of you, just because I know somebody probably has a question about this, 9 to the 3/2 power, I think of 9 as 3 squared. So if I take 3 squared and raise it to the 3/2 power, that is simply equal to 3 to the 3rd power, which would equal 27. So if this whole part equals 27, 27 times 1/3 is where I get the 9 from. I just went through that. You should know how to do that, be able to follow that. But just in case somebody was kind of struggling with, wait, how did he get the 9? That's where it came from. Okay. One more problem in our fun, awesome video lesson for today, and then we're done. Okay. So number 8. Take a look at number 8, if it will ever show up. There it is. Okay. Cosine, integral of cosine pi x dx. So we're going to let u, in this case, be pi x. And remember that we're going to treat pi just like a constant, just like any other number. Okay. So the derivative of u is just going to be pi dx. So if I divide both sides by pi, I get 1 over pi du equals dx. So now I can rewrite this integral, okay? And I'm going to go ahead and adjust my upper and my lower bound. So my upper bound, when I plug a 1 in for x, is just pi. And my lower bound, when I plug a 1/2 in for x here, I get pi over 2. Okay, so then I have the integral of cosine u times 1 over pi du. You can slide the 1/2, or I'm sorry, the 1 pi out to the front, and then you can evaluate the integral of cosine. Okay, the integral of cosine u is simply sine u. And again, we're evaluating this from pi over 2 to pi. So then we can plug in our upper bound. So 1 over pi times the sine of pi minus 1 over pi times the sine of pi over 2. And these are unit circle angles, so this shouldn't be too difficult for us. We get 1 over pi times 0, sine of pi is 0, minus 1 over pi times 1, sine of pi over 2 is 1. So the first term goes away, it just becomes 0. So this integral equals negative 1 over pi. Final answer. So I know that this video went pretty quickly. We did 8 problems really fast, maybe frustratingly fast for some of you. But again, feel free to pause, go back, rewind, fast forward, do whatever you need to do to make this video the most effective that it can be for you. Thanks so much, and I will see you next time. Bye, guys.